One pattern that is very popular in the DevOps space is this concept of pet versus cattle, and it's a anti-pattern that many people talk about. And the reason it's an anti-pattern is that because a server is so expensive and fragile, it causes big operational problems. So let's think about some things that fit this same pattern. I think smartphones in 2024 are really a pet that has many of the same characteristics as a monolithic server or synchronous messaging. So let's first take a look here at some of the characteristics of how a smartphone, a monolithic server, and synchronous messaging all have quite a lot in common. So first up here, if we look at a smartphone, it's on 24/7, right? Most people that have a smartphone have a cell plan that costs about $100 a month. And if you think about it, what's happening is that you have a bi-directional feed where you're constantly being interrupted throughout the day. So someone's sending you a message or you're messaging somebody back. You can see this if you go to Chipotle and walk into the line, you'll see that almost everybody's on their phone going back and forth. Also, you're paying essentially to get tracked by advertisers. So anytime you use a mapping service or use some kind of application, that's sending data to some advertiser that's going to collect that data and use it for you. And again, you're paying for it. We can also see that it's personalized as well. So your smartphone has all kinds of different things on there. So it has your music, it has your messaging, it has all these different things that hook you into it so that you grab it, let's say 200 times a day. And I think that's one of the things that's interesting about the smartphone is that in addition to the fact that it's a very inefficient architecture from a software engineering perspective, it's also extremely addictive. And it's really a question mark whether most people have to be available 24/7. I think there's some cases where you're a doctor that's on call, for example, that makes sense. Or you're a parent that maybe has a newborn that's in a nursery system. That could be a great example, or you're in law enforcement, et cetera. But I would say probably 95% of people, this concept of 24/7 availability is really a false pattern that potentially doesn't need to be there. And now if we go down here and we look at a monolithic server, this was how we used to build servers. We would have, let's say, a LAMP stack. And what would happen is you get a very expensive server, you put it into a data center, and it would just be grinding away 24/7. Even if nobody was using the server itself was running. So this is, again, very similar to a smartphone where even if you don't need it to be doing something, it's still actually doing something. And further, if we go into a software engineering pattern, we see this is like synchronous messaging. So synchronous messaging would be, having a permanent connection to a database. Like you have a socket connection open and you're just constantly going back and forth. The problem with this is that what if other people want to talk to that database, or, do you really want to pay for that, synchronous communication back and forth, and you're going to be using more resources, et cetera, et cetera. So these are generally considered by most people to be anti-patterns, right? This tight coupling, 24/7 availability, bidirectional, stateful, expensive, personalized. Now, if we look at the cattle approach here, which is really the standard for DevOps, for cloud computing, we can see a few things that are really, really interesting. So one of them is that, believe it or not, it really doesn't need to be the case that people are paying $100 a month for a self-service, because if you're doing batch-based operations, you don't have to pay anything. And most people at home or at a place of work, they have an extremely fast internet connection. For example, I have 8 gig fiber at home. I mean, that's so fast that in a second, I can download the whole state of North Carolina or the whole state of California, and then I've got that onto a dumb device. What's nice about this in terms of a comparison to a smartphone is that I don't care about which device has what. In fact, I can make single purpose devices. So inside of a vehicle, I can have music and navigation. And again, I can download the music and the map and the podcast, and they can always be batch updated, right? Like when you get back to your driveway, you just click batch updated and they go. Also, if you go into an airplane, you could have a very specific device. Maybe it's the device from your car. You just grab it, put it into your bag, and all it can do is do mapping and music. And likewise, maybe in your home, in your office, you have banking apps in your phone, and they're just tied together. And again, they don't necessarily even have to always be online. They could be, but they don't necessarily have to be. And what's nice about this is it's batch-based architecture. So when they need something, sure, they can go collect it. But then again, they're so cheap and inexpensive. Even if you lose it or it gets damaged, you really don't care. Basically just throw it away. Likewise with serverless, this is what many people think is a great pattern, is you have these disposable serverless instances like AWS Lambda, where you spin up something, it has something that's already installed on it. It goes away after it serves the request, and you can spin up easily 10, 100, 1,000 of these different compute instances. And you can see this as a comparison to the monolithic server, where, boy, if your monolithic server went down, there's chaos. You actually design for failure with serverless architecture. Now, if we get down to the software engineering layer here, we see that really this event-based messaging, where you have SQS or queue, and then the queue, there's some stuff in the queue, and then let's say a serverless compute is available, it'll process things from that queue and do the work. And this is really a superior architecture, I think, for most people, this pub-sub architecture, where when there's something to do, you do it, it's event-based. Otherwise, you don't do anything, right? You're not using any resources. Now, again, the opposite is that you have something just grinding 24/7. Even if you don't need those resources, it still has to be available. And you essentially have a leash. And that's what I see from a software perspective when we look at a smartphone. Effectively, somebody has you a pipe connected to a human being, and the pipe is constantly sending back and forth information. And like, do you really need that bidirectional feedback loop? I think 95% of people don't. There are some cases where it could be the case. Again, if we look at this from a software perspective, it's similar to having a permanent connection to a database. Almost never is that the case that you need that. Really, an event-based architecture is better, right? So you have maybe, again, in a vehicle, you have some communication when you get home, it synchronizes, or you go to your office, you open up a laptop and you do this. So I think what I see that as I kind of dive into here is that we've been sold that you need to have this, kind of pet-based approach to smartphones, but in practice, we need a cattle-based approach. And I've been demoing this, and it actually works extremely well. And even further, you can treat the cell phone itself as serverless. And in fact, if you use something like Google Voice, for example, one of the things that you can do is not even have a physical device anymore. And I will tell you this, it feels amazing to not be hooked to any kind of device where I even care about it anymore. I would say it's a massive improvement. So this is one of the things I'd like to promote more widely, is this concept of pet versus cattle anti-patterns. I think the current cell phone that's 24/7 on is in fact a huge anti-pattern that's similar to some of the anti-patterns that we had in the software industry in, let's say, the early 90s to the early 2000s.